Problem 8.11 is asking us at time t equals 0, a 22,150 kilogram rocket in outer space fires an engine that exerts an increasing force on it in the positive x direction. The force obeys the equation f of x equals at squared, where t is time, and has a magnitude of 781.25 newtons when t equals 1.25 seconds. A, find the value of the constant a, including the units. B, what impulse does the engine exert on the rocket during the 1.5 second interval starting 2 seconds after the engine is fired? And C, by how much does the rocket's velocity change during the interval? Assume constant mass. Okay, so we have a few knowns and a few givens. So our givens is that the mass of the rocket is 2,150 kilograms, and the force of the engine, F of x, equals 781.25 newtons at the time t equals 1.25. So some of the knowns are that net force acts on a particle from the time interval delta t from t1 to t2, and that the impulse j of the net force is given by the integral from t1 to t2 of the net forces in respect to time. So according to the impulse momentum theorem, the change in momentum during these time intervals equals the impulse of the net force. So that means that we have this, and we also know that momentum is given by this. So to calculate the things for part A, we rewrite the function of the force to be like this, and we plug in time 1.25, so we get 781.25 newtons equals a time of 1.25, and then solving for A, we get that A equals 500 newtons per second squared, and that is for part A. And then for part B, we substitute that the force of x equals 500t squared, and so we have t1 is 2 seconds and t2 is 2 seconds plus 1.5 seconds, so 3.5 seconds, and then we integrate. So into the equation from above, we get, so from 2 to 3.5 of 500t squared dt, and then you just put it in your calculator for integration, and you get 5812.5 kilograms meters per second, and that is for part B. And then for part C, we substitute from the equation I just used into the first equation I used. So we get therefore the change in velocity is this over this, and then we just plug in the numbers we have. So we do 5812.5 over 95,000, and that equals 2.7 meters per second, and that is for part C.